In this collection of videos, we're going to take a look at building our first OLAP database using SQL Server Analysis Services. Now, the example that we're going to use is going to be the AdventureWorks database that comes with SQL Server, and we're only going to use a portion of it. We're not going to use the entire AdventureWorks database, just a portion of it for this first example. Now, we're certainly not going to go through every feature that's in Analysis Services, certainly not for this first example, but we want to show enough features from Analysis Services so that you'll have an idea of what types of capabilities exist in Analysis Services and what type of analytic databases that we can create for end users. Now, in this first example, if you take a look here on the left, one of the things that we'll be able to do with this database when we're finished is allow the user to access it with Excel. Excel is arguably the most popular way for end users to be able to get at an analytic database. Well, the database we're going to construct is one that's going to reflect the two different sales channels in AdventureWorks. There is an internet sales business process, and there is a reseller sales business process. There are two different sales channels in AdventureWorks. This first one here for sales amount is for sales that go directly to customers on the internet, and this reseller sales amount is sales through a vendor channel. And there are going to be some common dimensions that we'll be able to look at this data by. We'll be able to look at it by year or by any aspect of the date dimension, by product categories or subcategories, by geography dimension. So we see here that we got a breakout of both internet sales and reseller sales by country, and then by state, province, and by city, and so on. So after we go through the process of building this in Analysis Services, the end user will be able to get at the data very easily in Excel and do groupings and do the proverbial slice and dice that users want to do with a tool like Excel. Now, over here on the right-hand side is the feature matrix, is the dimension matrix that we're ultimately going to build. So we see that we have two primary measure groups here: fact internet sales, again, which is sales directly to the customer through a website, and the fact reseller sales, which are sales that go to resellers, to vendors. So we see we have some dimensions that are in common here, but the internet sales is only through customer and the reseller sales is only through reseller. It's not uncommon in an OLAP database to have gaps here, where fact tables have some commonality, have some conform dimensions, but also have ones that are specific just to that fact table. Now, we're also going to want to look at both internet sales or reseller sales by geography, as we see over here on the left. Well, in order to do that, we're going to have to build what's called a referenced relationship. As we're going to see with the data, the internet sales and reseller sales don't have a direct association with the geography definition for where the sale took place. We're going to have to bounce off of the two inside dimensions on customer and reseller in order to have a common dimension on geography. So as we get to that point, we'll actually take a look at that. Now, anytime we build any type of an OLAP database, there has to be a source. There has to be a source of data. In this instance, the data source is going to be the data warehouse or the data mart that Microsoft provides, called AdventureWorks DW. So if I hop over here to Management Studio and I take a look at the list of databases, one of the databases here is AdventureWorks DW 2008 R2. And if I expand the tables, I see all the tables that are in AdventureWorks DW 2008 R2. This is just a relational database structured in a fact dimension methodology, so that we can look at measures by the related business entities. Now, we're not going to use all of these for this first example. We're going to focus on just a handful of tables. The ones that we're going to use are going to be down at the bottom here: fact internet sales and fact reseller sales. Now, in later examples in class, we'll bring in other tables like fact sales quota and fact currency rate and some other ones, but for right now we're going to focus on fact internet sales and fact reseller sales. Now, we're not going to want all of the columns in these tables. If I expand fact internet sales and expand the columns, I see that we have a series of measures down here: sales amount, tax amount, freight, total product cost. We'll bring those in. And the foreign keys that represent the dimension pointers for things like product key, order date, due date, ship date, customer key, promotion key, we'll certainly bring those in. Some of the other ones like currency key and sales territory key, we're going to leave those behind. We'll save those for another day. Now also notice that this data warehouse, this data mart, has the original sales transaction number. Well, in an analytic database, we might or we might not want to bring that in. It all depends upon what type of analysis that people want to do in things like Excel and other analytic reporting tools. If they need to drill down to see individual sales orders, then yes, we need to bring that into the OLAP database. In this example, we're going to actually omit the sales order number and the sales order line item number and basically collapse the data by product, by date, by customer, and by promotion. So we're going to construct a couple of views that we're going to use as the basis for building this OLAP database. So I'm looking at a script right now with some views that are created in AdventureWorks DW 2008 R2. I've got a view here called VW Fact Internet Sales, where I'm going to pull forward the product key, the order date key, the due date key, the ship date key, the customer key, and the promotion key. And I'm going to sum the four major measures: the total product cost, the sales amount, the tax amount, and the freight. So again, I'm basically collapsing this data by these dimensions, and I'm not bringing forward the transaction numbers. In some analytic databases, transaction numbers might not be important. It all depends upon the type of analysis someone is doing. So for both Fact Internet Sales and for Fact Reseller Sales, I'm going to collapse them by a couple of dimensions. Now, notice how in Fact Internet Sales we have a customer key, and in Fact Reseller Sales we have a reseller key. So we do have a couple of columns that are different. The measures here are very similar. Actually, they're identical in structure, but they represent the sales and the cost through the two different business channels. So that's why we have these in two separate fact tables. Now, going through some of the other views in here. In the source data, there is, if I come up here further, there is a product dimension, there is a product category, and a subcategory dimension. Now, unless there is a compelling reason in an OLAP database or even in a data mart to normalize those in separate tables, it's actually a recommended practice to denormalize these for reporting purposes. So in the view here, I'm going to create a view called VWDIM product, where I'm going to join product, product subcategory, and product category on the primary keys, four keys between the tables. And I'm going to bring forward a subset of the columns. I'm going to bring forward the product name, the product business key, the product key, the subcategory, the category, the color, the safety stock level, the model name, the list price, and so on. Because I want to be able to look at sales grouped by product list price, or by standard cost, or by size range, or by color. So those are the attributes I'm bringing forward. So again, we're going to denormalize those three separate tables into one table. Well, there's also a date dimension. Every OLAP database is going to have a date dimension. That's almost a given. The ability to look at data over a period of months, quarters, years, whatever data attributes you happen to have. That's common in just about every OLAP database. So we're going to create a view called VWDIM date that's going to extract a handful of columns from the date dimension. And if you remember, the date dimension is simply a calendar that spans a couple of years, where we have the dates and their corresponding month, quarter, and so on, so that we can look at data by any of these data elements. Now, when we actually construct the OLAP database, we're going to look at this data in a little bit more detail. There's also a promotion dimension. If I come back here to the slide deck, both fact tables are also accessible by the promotion dimension. Now, most of the sales in AdventureWorks actually don't have a promotion code on them. So it's just basically a non-promoted sale. But occasionally there might be different promotions that occur based on volume discounts, or maybe a product that's going to be discontinued. So there's a promotion key on the sale. So we'll bring forward some of the elements from the promotion dimension. Then there's a customer dimension. Now again, the customer dimension is only tied to the fact internet sales side, but that allows us to take a look at sales by customer name, roll up sales by the marital status to see what percent of single people are buying products versus married people, male versus female as far as sales go, sales by income range, sales by English education. So we'll bring forward a couple of attributes from the customer dimension. In practice, a customer or a resident dimension might have demographics that might cover dozens, or in some cases maybe even hundreds of attributes to describe that person. So some databases might be very, very heavy on the demographic side, and there might be many different attributes per person. We have the reseller dimension, which is the list of vendors. We have the reseller name, the product line that they're associated with, their business type. And also notice in both the customer and the reseller dimension there is a geography key. The geography data is spread out in is covered in a separate table. So we have a separate dimension called VWDIM geography, where we have the geography key that's related back to the customer and the reseller dimension, the state name, the country name, and the postal code. So this is the data that we're going to bring forward into the OLAP database. So I'm actually going to execute this view. So I'll take execute, and that has created a series of views in my version of AdventureWorks. If I actually come down and expand the views, well, I see I've got VWDIM date, I've got VWDIM product, I've got VW fact internet sales. So I've got a series of views that I'm going to use as the basis for this OLAP database. Now, you might also notice here, and this is only because of what's on my machine, I actually have another set of views that begin with the letter V. If you're wondering what's the difference between the ones that begin with VW and the ones that begin with V, those are actually from a separate exercise. What I'm going to do here, just so that there's no confusion when I go through this exercise, these different views that seem to have the same core name as the ones I just created, I'm actually going to get rid of these. So just a temporary detour here for just a second. The ones that begin with the letter V, I'm actually going to get rid of, so that there's no confusion between these and the ones that we're going to use in this exercise. Again, these ones that begin with the letter V were from another exercise. I can recreate them at any time, so I'm just going to get rid of them here. That way there's no confusion with this exercise. Okay, so here are the views that we are going to use. So we have two fact tables, and then 1, 2, 3, 4, 5, 6 different dimensions. Now, actually, I'm going to take just a quick look at some of the data that's in these views. So just going through here, if I take a look at VDIM customer, let's say select star from VWDIM customer. Well, that has each customer. We have about 18,000 customers who have bought products in the internet sales channel, their marital status, their gender, their yearly income. And notice how we have a nice short list here of different yearly incomes. If we actually had the actual value, we'd have far too many values for it to be of any analytic significance. So we've got them broken out into ranges of $10,000, and the person's education level. Now notice we also have this geography key. We'll see the geography dimension in a minute. So that's VWDIM customer. Well, we also have VWDIM reseller, and that has our list of vendors. So we have vendors like Progressive Sports, Associated Bikes, Sharp Bikes, etc. The product line that they deal with, their order frequency. So these are different attributes by which we might want to look at sales data. The type of vendor that it is, and also the geography key. So we have the geography key in two separate tables, for customer and for reseller. Well, let's take a look at the actual geography master. So I'll take a look at VWDIM geography. Well, VWDIM geography has the core list of geographies. Now this is down to the city and postal code level. It's not down to the street address level. Maybe we don't need to do any kind of analysis at a level lower than postal code and city. So we've got a nice short list here of 655 different geographies for different cities and states and countries in this database. So we'll be able to look at sales by any one of these attributes. Well, continuing on here, we have the date dimension, and this is pulling forward a handful of columns from the core AdventureWorks date calendar. So we'll be able to look at sales by date itself, by the day of the week, by the month, by the quarter, by the calendar year, and by the fiscal quarter. So we've got both the calendar and the fiscal definitions in here. And then continuing on, we had the product dimension. And the product dimension has the products, so we have just short of 400 products, where we have the product alternate key, the business key, the name of the product, the subcategory and category to which it belongs, and then some different attributes. If we want to look at sales by product color, or by safety stock level, or by model, or by standard cost. And then we have the promotion dimension. And again, these are views. Oops. These are views on top of the original data, because maybe we want to summarize things, or maybe we only wanted a handful of columns in this analytic database. Now, most of the sales take place under a no discount condition. So most promotion keys are going to be 1 in the actual fact data. But anytime we had volume discounts or discounts for a product that was going to be discontinued, we have a different promotion key that was used on the sale. So this allows us to look at sales by promotion. And then we have the two fact tables. So if I query from VW Fact Internet Sales, well, this is the sales and the tax amount and the freight and the product costs and so forth by product, by customer, by promotion key. And notice how we have these 3 different dates here: order date, due date, and ship date. If you remember from the data warehousing, from the initial discussion in the data warehousing section, we said that an individual key in a dimension can serve multiple purposes in a fact table. Well, that date is serving 3 different purposes here, for order date, due date, and ship date. That'll allow us to look at sales for a year based upon one definition, like when the liability for the order is booked, versus when we actually ship the product. So that's a role-playing dimension. And then we have reseller sales, which is similar in structure, but represents a completely different business process. It's sales by reseller, not by individual customer. Now we have the same measures that we're going to roll up: product cost, sales amount, tax amount, and freight, but it's through a different business process. So this is our relational data. So whether we're looking at medical data, basic sales data, or other types of company data, we've got this information in views, in a fact dimension model. How can we go from this to building some kind of analytic database where people can go in and slice by the related dimensions? Well, that's where analysis services comes in. And so in the next video, we're actually going to take a look at the first steps to create the SSAS project.